Good evening, everybody. So, this is the third lecture of the unit number 3, part 1, pipe flow. In the first lecture, we introduced pipe flow and then we discussed about the Reynolds experiment. In the second lecture, we discussed about the various energy losses in pipe flow. Then, in today's lecture, we derive the equation for the major loss which is due to friction. The equation for the major loss is Darcy Weishback equation. And this Darcy Weishback equation is applicable to turbulent flow. However, by making the friction factor F is equal to 64 by Reynolds number, that is precisely friction factor F is equal to 64 divided by RE. We can use the same equation for laminar flow also. So now let us start deriving the Darcy-Weishback equation, which is the equation for head loss, equation for major energy loss, equation for the loss due to friction in case of pipe flow. Let us straight away go into that. Derive the equation for head loss. Due to friction, or derive Darcy-Weishback equation. And the equation is HF is equal to FL V squared by 2GD. This is the equation. For that, what I am going to do? Consider flow through a pipe of diameter D. Let V be the velocity of flow through the pipe. Suppose if I draw, this is the pipe, this is the flow. I consider two sections like this, section 1, section 2. These are the two sections. Now the pressure at this section is the various forces. If I take it, this is the pressure at this section, whereas the pressure at this section is P2. So the flow in this pipe is subjected to the pressure forces at both the sections and also the frictional resistance. So this is the frictional resistance. If I call this as F, right? These are the three forces actually. So right now, if I take it, the length between the two sections is L. right? Now, if F dash is the frictional resistance, frictional resistance per unit area at unit velocity, the total frictional resistance is equal to which I call it as F is equal to basically F dash into, this is the frictional resistance, into what is the area basically. It is the area per unit area he mentioned. So what is the area? Area is nothing but the surface area into velocity to the power of n. First thing is, what is this surface area? When flow is taking place through the pipe, if you are considering these 1 and 2 sections, the flow between these two sections, what is the surface area? Surface area is nothing but the perimeter. You imagine, you take a pipe, so two sections. So what is the inside surface area where the water is being in touch? That is the perimeter. In to be precise, if you want wetted perimeter, whatever area is, whatever the perimeter it is wet into length. So this we call it as P into L. Then why V to the power of N? Because normally we know that in the case of laminar flow, the head loss is proportional to V actually. But when we move into the turbulent flow, that means as the velocity of flow is increased, when we move into the turbulent flow, the relation between the head loss and velocity, it is changing such that it is to V to the power of N, and the maximum value of n is, the maximum value of n is 2. So here I want to impress upon you that in case of laminar flow, if you take it, the head loss is proportional to velocity. They vary linearly with velocity. It is linear variation. Whereas in case of turbulent flow, if you take it, HF is proportional to V to the power of N basically. It is what we call it as the logarithmic variation. So that is why as we are dealing with the turbulent flow, I have taken this. But what is the maximum value? What is N value? N value maximum it can go to 2 value. Maximum n is equal to 2. So that's why that if I keep it like that, then total frictional resistance F is equal to F dash into P into L. This is the surface area into V square. This is equation 1. You call it as, this is over. Now what I do, now you take it, basically taking the whatever the forces that are acting, the various forces acting on the fluid are: number one, pressure force at section 1, which is equal to P1 into A, which is equal to P1 into pi d square by 4. Then pressure force at section 2, that is P2 into A, which is equal to P2 into pi d square by 4. And what is the third force? The total frictional force. Frictional resistance. What is it actually? It is F is equal to F dash into PL into V square. Now, if I take the resultant of these forces, then P1 into pi d square by 4 minus P2 into pi d square by 4 minus F dash into PL into V square is equal to 0. Therefore, P1 minus P2 into pi d square by 4 is equal to F dash into PL into V square. Then again P1 minus P2 is equal to, then if you take it on that side, 4F dash P into L into V square by pi d square. Right? Now, what is P? P is wetted perimeter, and as section is circular, then P is equal to pi d. Therefore, P1 minus P2 is equal to 4F dash into pi d into L into V square by pi d square. So cancel pi, d cancel if you do it. Then if you are getting it, 4F dash into LV square by basically we get D. This is what we get. So divide both sides with the gamma. Divide both sides by gamma, that is specific weight. Therefore, P1 minus P2 by gamma is equal to 4F dash LV square by gamma into D. This is next. What is P1 minus P2 by gamma? P1 minus P2 by gamma is nothing but the head loss HF, and HF is equal to, then if it is 4F dash into LV square by gamma D. So next, replacing 4F dash by gamma with F by 2G, that is 4F dash by gamma is equal to F by 2G. Therefore, HF is equal to FLV square by 2GD. This is our equation basic. So now you may ask me, sir, how P1 minus P2 by gamma is equal to, how P1 minus P2 by gamma is equal to HF? This question, man. Now it is very simple actually. This is the horizontal pipe which you have taken, and these are the two sections 1 and 2, right? Then if I take it here, the pressure is P1, here the pressure is P2. So applying Bernoulli's equation between 1 and 2, what is it you tell me? P1 by gamma plus V1 squared by 2G plus Z1 is equal to P2 by gamma plus V2 squared by 2G plus Z2 plus HF. This is what? And this diameter is D. Right? So as pipe is horizontal, right? Z1 is equal to Z2 as pipe is uniform diameter, that is D1 is equal to D2 is equal to D. Therefore, V1 is equal to V2. Therefore, P1 by gamma is equal to P2 by gamma plus HF. Therefore, HF is equal to P1 by minus P2 by gamma. So this is how I have written that. So if you want this also you can incorporate there itself. So finally the conclusion point is the head loss due to friction is FLV squared by 2GD. What is this equation? This equation is called as Darcy Weishback equation. As already mentioned, this is applicable to only turbulent flow. But sometimes if you want to use the same thing, this equation can be applied to laminar flow by replacing F is equal to 64 by RE. This is the way which we need to do it. If you can do this, then you can use it for laminar flow also. Otherwise, this equation is mainly used for turbulent flow. Some of the British textbooks, initially itself, they have written HF is equal to 4FLV squared by 2GD, right? So they don't confuse with these two. So what whether you use this equation or this is fine, but for me, in order to avoid any confusion, I use only FLV squared by 2GD. In this equation, in the above equation, F is called as friction factor. F is called as friction factor. L is the length of the pipe. V is the average velocity. D is the diameter. Here is F. Here F is called as coefficient of friction. Please remember this F is equal to 4F dash. You can recognize whether friction factor or coefficient of friction depending on value given for friction factor. Yesterday itself I mentioned friction factor generally it will be of the order of 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07 approximately it will be in this order. Whereas if I take it the F dash, this is coefficient of friction 0.004, 0.005, 0.006, 0.007, 0.008, 0.009, right? In this fashion it will be. So by looking at these values, you can take it. If suppose this value, if F dash is given, then immediately multiply by 4, right? Friction factor. F is equal to 4F dash. So apart from that, there is absolutely very easy in this particular thing. So now we have taken up this particular what we call it as the energy losses in pipes. In that, the major energy loss which we have taken, which we call it as energy loss due to friction. This we have completed this derivation. So in the we stop this lecture at this place. So we have completed the derivation of Darcy Weishback equation. Please practice this Darcy Weishback equation twice, thrice without looking into it. And if you have any doubts, kindly talk to me in any of the classes or any of the time whenever you are free. So with this, we will stop this at this stage.
Like, share, and subscribe. Hit the bell icon for more updates.